Okay, so the first one that I gave you was finding the domain of a function. This one does not have a variable in the denominator, and it doesn't have anything under square root, which means it's all real numbers. In interval notation, that's a negative infinity to positive infinity. Is infinity a defined number? Can you give me infinity dollars? No. So infinity will never have a bracket. Okay? Same thing for negative infinity. There's not an actual number there. You'll never see a bracket on those. So if you're giving negative infinity or positive infinity, it will always be a parentheses. Okay? Questions on that one? Most of you got that one right. Okay. The second one was, now there's a square root in the numerator and a variable in the denominator. So the square root in the top, we said greater than or equal to 0. You would have gotten that 2x had to be greater than or equal to 3/2 or 1.5. And then your denominator says that x also can't equal 4. So if you pictured it on a number line, it would have gone from from 3/2. It would have been a bracket, and it would have pointed to the right if it was just that one. But there's a hole at 4, which means I can't include 4. So I'm going to go from, and this is exactly right, I'm going to go from 3/2 with a bracket on the 3/2 because it can include it, up to 4 with a parentheses on the 4, union 4 it picks up again to positive infinity. So in inequality notation, you would write this, but x cannot equal 4. But in interval notation, it should look like the one there on the bottom. Questions on that one, Amanda? Because you think about what happens if I plug in 3/2 in the numerator, I get 0. And 0 can be in my numerator, it just can't be in my denominator. Okay? Because 0 is an answer, right? It's a real number.
Thank you.
You're welcome. Any other questions on domain before we go on? Okay. And then the next was your difference quotient. So remember the difference quotient is f of x plus h minus f of x over h. So it's something you've got to remember. So you want to take, this is first the f of x. So this work here to there is finding the f of x plus h. So she took f of x, she took x plus h, plugged it in to the x here and the x here, expanded the x plus h, and remember you're going to do x plus h squared a lot, so if you want to memorize it, go for it, which is x squared plus 2xh plus h squared. Then distributed the 4 in, distributed the negative 2 into the x plus h, and then from there, you couldn't combine terms yet, but that's what's on the bottom here, so that was this line. This is what you get from f of x plus h. And then you want to subtract from it f of x, which is this part here, okay? And remember, it changes all the signs. So the 4x squared becomes negative, the 2x becomes positive, and the negative 3 becomes positive. Combine your like terms from there. The 4x and the negative 4x cancel, negative 4x squared cancel out. Negative 2x, positive 2x cancel out. Negative 3, positive 3 cancel out. And then you're left with 4h squared plus 8xh minus 2h. And the last step is it all goes over h. And you reduce it. And your ending answer should have been this. And again, I'll take it in different order. Okay, your book puts it in this order. Typically, they'll put variables in alphabetical order. So you see 4h plus 8x, and then the one without the variable comes last, which is that minus 2. But your test for this will be open-ended. So if you mix up that order, I'm okay with it. If you put the 8x first, whatever, it's fine, as long as the signs are right. How many of you got the difference quotient one right? Good. Okay, any questions on any of the stuff that we talked about yesterday? Okay. All right, so 1.3 is graphs of functions. So yesterday we talked, and the day before, we talked all about functions by way of an equation or points, okay? Now we talked about domain and range from an equation. Now we're going to talk about everything from a graphing standpoint. So everything flips so that's graphs. All right, so we're going to start with domain and range. We talked about domain from an equation. Now we're going to talk about it from a graph. So domain, when you're looking at a graph, are all the values from the furthest point left to the furthest point right. Think about domain as your x coordinates, right? So all the way left to all the way right. And then range is your y values, what you can get out of the graph. So this would be the values from the bottom to the top. Your answers for domain and range are going to be in interval notation. That's why we're kind of baby stepping our way into it. Now it has to be. Finding an indicated value is just like evaluating a function. So you're going to find the y that matches whatever's in the x that's inside the parentheses. So when we did these algebraically, and I asked you to find f of 2, you would have taken whatever f of x is, right? And taken the 2 and plugged it in where? Into the x. So the 2 is the x. On the graph, you're going to go to where the x is 2, and you're going to give whatever the y is that matches it, okay? So a lot of times you'll see standardized tests write stuff like this, okay? That is a point disguised in function form. Whatever's inside the parentheses is your x, and whatever it's equal to is your y. So this is the same thing. So if I asked you to find f of 10, you would go to where x is 10, look at the graph that's there, and give the answer for the y coordinate. All right, so this one says, find the domain and range, and then the indicated function values. So this time you're given the graph, right? So let's start with domain and range. The domain is what coordinate? The x. So I'm going to the furthest x on the left, which is what? What's the smallest x there? This would be a -1, -2, -3, -4. This is a 1 and a -1. What's the smallest x? -4. Is it a bracket or a parentheses? Bracket. That is a solid point there. It would be an open dot like that if it wanted a parentheses. Okay. What's the end of the domain? Where does it end? -1. And again, open dot would mean parentheses, so a closed dot means? Bracket. There's my domain, left to right. There's no breaks, it's one continuous, okay? Eventually we're going to get into piecewise functions. You might see breaks and stuff where a domain could start and stop and start and stop. This one is one fluid curve. How about range? -2, and again, it's a solid dot, so that's the lowest y. What's the biggest y that's there? +2. Is it a parentheses or a bracket? Bracket. So this is considered a line. A line is full of solid dots, right? If it wanted you to put a parentheses, you would see an open dot at that space. Okay? So open dot, parentheses, closed dot, bracket. Good so far? Questions?
It's always bottom to top.
Yep, range is bottom to top, domain is left to right. Because you're going small, so you always write interval notation in order of value, smallest to largest. So we go left to right on the x's, bottom to top on the y's. Do the second part. Second part says evaluate the function, right? Or find the indicated function value. So f of -4 means I'm going to where x is -4, which would be this line here, and I'm finding where the y is that coordinates with it, which is what? -2. F of -1 would be 1. Everybody see that? Questions? Oh wait, I did. All right, now we're going to use the graphing calculator. So if you have your handheld, get used to it. It's a good thing, okay? Go ahead and open it up, turn it on, wake it up. If you don't and you want to use the graphing calculator on the iPad for this, it's totally fine, okay? But by test time, which is week after next, you need to have a graphing calculator. You're going to get a question in which you won't be able to do it without. So you'll do part of your test without, and then one question or about one question worth a lot of points, actually, with. So you'll have to do it. All right, so I'm going to graph f of x equals x, absolute value of x plus 2. On the graphing calculator, you do have the little bars, some of you, but the rest of you, you'll go to your math menu. So the first thing I'm going to do, if you've never graphed on your graphing calculator, is I'm going to go to the y equals at the top button. And then you're going to go to math. Go over to NUM, which is the second little tab on the top. And I think it's the first thing in the list, right? First thing in the list is A, B, S with the parentheses. That's your absolute value. You're going to type that. and then you're going to enter x plus 2. Your x is the little button that says x, comma, t, comma, theta, comma, I don't even know what else is there. Okay, but that's your variable button. You don't have to use the text x. Okay, that's your variable button. And then you're going to do the plus 2. All right, so I graphed it, right? This says use the graphing utility to graph the function, estimate its domain and range, and then verify the result algebraically. So think about what's happening at the edges of these screens, whether you're looking at a small zoomed in view or you're looking at one that's really zoomed out. What happens on the edges of this V? They disappear like it gets cut off, right? What is that implying? It's going to keep going. Like there's arrows at the end of there. So what's the furthest point left on this? Negative infinity. What's the furthest point right? Positive infinity. So that's your domain. Domain would be negative infinity to positive infinity. Okay? And your range, so what's the lowest point? 0. Bracket or parentheses? Bracket. And the highest point? Infinity. Because again, it would keep going up and up and up. So remember, domain, left to right, range, bottom to top. Okay? Is infinity a number? Can you give me infinity dollars? No. So you will never see a bracket on infinity. Okay? Ever, 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 ever. Because you can't include that number, right? It's not something you can plot. Okay? So be careful with that. All right, then it says verify the result algebraically. So think about what we did in the section that we just finished. If I was asking you for domain of f of x equals x plus absolute value of x plus 2, is there a restriction as what I can plug in there? Is there something that makes an absolute value undefined? No. So the answer there, domain is all real numbers. Does that make sense? It should match your graph. How about what you get out of it? So think about what happens with an absolute value. No matter what, right? Absolute value, unless there's something on the front of it. Absolute value is always going to make something positive. Smallest absolute value of a number you could find is 0. Does that make sense? So that's why your range is 0 to positive infinity. Okay? So domain is what can I plug in? Range is what would I get out of it. Okay? The vertical line test. This is like the easiest thing you will learn. As long as you know what a vertical line is, and you can write YES or NO, you can get this question right. So the vertical line test is used to determine if a graph is a function. So this is our third test. If you remember in 1.2, we did from points and we did from an equation, and now you can do it from a graph. If a vertical line hits a graph at more than 1 point, the graph is not a function. So the question for example 2 says, use the vertical line test to determine whether the curve is a graph of the function of x. If it is, state the domain and range of the function. So the first part is just your simple yes or no. So if I look at A, if I draw vertical lines, do any one of these vertical lines hit that graph at more than 1 point? No. So the answer first is yes, this is a function. Now I'll go back and find domain and range in a second. Go on to B. If I draw vertical lines here, do any of these lines hit that graph at more than 1 point? Yes, which means not a function. It just takes one line, one vertical line to make it not a function. So there's going to be some funky graphs. Like if I saw something like this, here, fine, here, fine. As soon as I get there, it fails my vertical line test. That's not a function, okay? So overlap this with what we talked about before in section 1.2. When you were given points, when were those points not a function?
When they had the same x.
If you have a same x, repeat with a different y. Does that sound familiar? Hopefully, yeah. So think about what happens here. If x is 1, what's true about my y's? Do I have one y that matches x being 1 or more than 1? More than 1, okay? The second test was based on an equation, right? So this is an ellipse, which if you remember is an x squared and a y squared. So the center is like it's something over a number plus y squared over a number, kind of a thing, okay? But the rule on the equation was that the y can't be raised to an even power or an absolute value, right? So this graph fails the vertical line test. The points would fail the point test, and the equation would fail the function or from the equation, that y cannot be raised to an even power or in absolute value. Okay, so they all overlap. Okay, so now that we know this is a function, let's get the domain and the range. What's the domain here? What's the smallest x that's plotted? 0. Is it a bracket or a parentheses? Bracket. What's the furthest to the right or the biggest x? 4. Also a bracket, right? Because it's not an open dot. And the range, smallest y is 0. Biggest y is 3. Questions on vertical line test, domain range, any of that? Okay, finding the 0 of the function. So the first time around, this said find when f of x equals 0. Same set of directions, different set of directions, same exact method. So if it said find where f of x equals 0, I'd set the equation equal to 0, I'd solve it. So you were factoring these and solving. You're going to do the same exact thing. The wording here is going to change, so you want to become aware that the word zeros is the same thing as finding the roots. It's the same thing as finding the x-intercepts. It's the same thing as finding the solutions. All of those mean the same thing. So roots, zeros, x-intercepts, solutions, or where f of x equals 0, all mean the same thing. For every single one of those, you'll set your equation equal to 0, you'll solve it. From a graph, you'd be looking for where it crosses the x-axis. Okay, those are your zeros, your roots. Okay, increasing and decreasing behavior. So you're going to read this from a graph. It says moving from left to right. So your interval notation will go in the order of smallest number to largest number. If the graph is rising as you're moving from left to right, then the graph is increasing. If it's falling as you move from left to right, then it's decreasing. The third option is if it's constant. So if it's flat or horizontal, then it's constant. And your answer is going to be given in interval notation. All right, minima and maxima. Okay, we shorten these as max and min. So there's two different types of max and min, absolute and relative. Absolute only has one. There's only one absolute max, one absolute min. But relative is every time the graph goes up and comes back down, there's a relative max. Every time it goes down and come back up, there's a relative min. So you can have more than one of these. And you'll give the answer in point form, coordinate point form, where it's an x and a y. All right, so this one kind of puts it together. Use the graphing calculator and then identify the max and the min, or the relative max and min. There should be a minus in between those two. It should be negative 2x squared minus 9x. Be careful when you type this into your graphing calculator. There's a negative button, okay? You can't use the minus button on the front. You can use the minus in between, but you can't use it on the front. It'll tell you have like a syntax error, okay? And that's what that means. So if I type this in, negative 2x squared minus 9x, and I hit graph, on the graphing app, it appears like this. On your graphing calculator, the very top of it might get cut off, right? So this is where you can adjust your zoom if you want, okay? So adjust your window so that it includes, maybe go up to 11 on your Y max. So you want to start to get to know how to adjust that window so you see it to the best that you can. If you double tap your screen on the app, it will let you, it says find max min. You tap it and it brings you right to that point and it identifies the point. It's in the top left corner. On a graphing calculator, once you hit graph, you have a button that says calc. So if you hit second trace, there's a button that says calc, and you can click on max. Some of them bring you straight to that point. I don't know the difference, to be honest. I guess I need to do like a research project on this. Some of you bring you straight to that maximum point, and some of you will have to trace it. You want to get as close as you can. It doesn't have to be exact when you're tracing. But if you notice here, this point, right, there's only a maximum here. There's no minimum. It doesn't go down and come back up. It doesn't go up and come back down multiple times. There is just one max on this graph. And that maximum is negative 2.25 and 10.125. So, yep, you can use your table, except it's not going to be exact, right? It's more, if you can see that it's not exactly at the 10, I would use that trace. So what about domain and range on this function? And then we'll stop here. What's domain on this function? All real numbers, negative infinity to positive infinity, right? Goes all the way left, all the way right. How about range? Good. Negative infinity to 10.125, and it includes that point, so it gets a bracket. How about increasing, decreasing? So we're going to go from left to right, which means the first curve I want to look at is from here to here. What's happening there? Increasing. So it's increasing from negative infinity, and increasing, I'm giving the left to right. To the left to right, which would be negative 2.25. And then it gets a parenthesis, and then decreasing from negative 2.25 to positive infinity.